let's continue reviewing in Unit 2 to get ready for our next exam. So the next ones we're going to look at are about reading measurements on various measurement devices, specifically a Vernier caliper and a metric micrometer. So for reading a measurement on a Vernier caliper, the first thing we're going to do, which I'm going to just refer to it as step 1, is we have to kind of get the whole part of the answers. Now when we read this in metric units, the units that this is ultimately going to be in are going to be in millimeters. And for step 1, we're going to find the tick that is to the left of our 0 mark. So if I look on my scale, here's my 0 mark right here. Now we're not looking down here at the bottom scale at all, right? This is going to be rating this in inches, which we are not going to be talking about in this course. We're just going to be doing the metric one, which is going to be the information on this top scale. So looking at here, for where I have my 0, which is occurring on the Vernier scale, I'm going to look at what's happening on my fixed scale. So down here on my fixed scale, this is 4 centimeters, which is the same thing as 40 millimeters. So I want to find the first tick that is to the left of 0. So if this is 40 millimeters, this would be 41 and 42. Right, so and then after that I get to the right of the 0. So the last tick that is to the left of 0 would be 42 millimeters. So I'm going to record that over here off to the side. Now if you wanted to, you could write this as 42.00. Right, so 42 is kind of the whole part of the reading. Now we're going to go down into the degrees of accuracy into either tenths or hundredths spot, which is going to be what I'm going to call step 2. So for step 2, we're going to find the first line on the Vernier scale that aligns exactly with a line on our fixed scale. All right, so if I'm coming across here and I'm looking at these lines, all right, maybe I'll grab green right here. All right, so these ones, and we're doing this to the right of 0. All right, so I'm just going to be coming across, going line by line, matching up what's happening up here with what's down there, and I'm looking for an exact match. All right, so if we kind of come across here, this one is starting to look really close. So does this one, and so is that one, maybe that one, and then they are going to start getting off again. So there's going to be a little bit of latitude on these. If you have a range of values that you think line up exactly, I would say probably just pick some line in the middle of that range, not on the extremes. So if I were to pick this line right here, I think that one is where that line lines up exactly with the Vernier scale to the fixed scale. So looking at these ticks up here, the long graduations are going to be what numbers are going to be in your tenths spot, and the short graduations are going to be the halfway marks that would be in the hundredth spot. So if I think I'm at this line right here, that's halfway between 3 and 4, or halfway between 30 and 40, if you want to think about it like that, which would be at 35. But those are going to be over here in the tenths and the hundredth spot. So I would have 35 or 0.35 millimeters for my kind of my finer reading, and if I put this all together, I would end up at 42.35 millimeters for my reading. Now, again, there's a couple of values on this, depending on how zoomed in you can get and what's reading on here that I would say would be valid. If you had wanted to read, or if you had thought that this value was the one that lined up exactly, so the tick mark at the 4 lines up exactly with what you're seeing on the fixed scale, that one for the final answer would still have 42 for the whole part, but then it would have 40 millimeters for the finer graduations. So either one of these in my mind would be acceptable answers. So again, there's a little bit of latitude. There are answers that are absolutely going to be wrong, but either one of these I think would be acceptable for a final answer on this type of question. All right, so let's read another type of measuring device. This one is for a metric micrometer. All right, so on this one, for step 1, we're going to read the barrel. All right, so looking at the barrel for where the barrel hits the part where the head meets the barrel, we're going to be at 10, and then this would be at 10.5. Then this next tick would be at 11. And then this tick right here would be 11.5, and then I don't have another tick. So for reading the barrel part, I would be at 11.5, and then again, my units at this point in time are millimeters. All right, so that's step 1. For step 2, we're going to read what value we get on the head of the barrel. So looking at here, I've got, and we're going to see where the head meets the center line that's on the barrel exactly. So looking at here, I've got 30, 31, 32, 33, and 34 meets the line on the barrel exactly. So that would be 0.34 for the reading. I would add these together. So this would give me 11.84, and then my units are in millimeters. All right, let's take a look at this next one. So this says, use the rules for addition of measurements to sum the following: 16.8 centimeters, 19.7 meters, 0.14 kilometers, and 240 meters. So the first thing that I'm noticing is that I need to get everyone in the same unit. I've got some guys in centimeters, some in meters, and some in kilometers. So when in doubt, let's get everybody to the base. If you're already told what unit to get everybody into, you could just do that, but because we weren't told, we're just going to get everybody in terms of meters. All right, so the first one, 16.8 centimeters. To get that into my base unit of meters, again, we have the mnemonic that we can use to help us remember how to move the decimal point. King Henry died by drinking chocolate milk. All right, so in this case, I'm in centimeters, and I want to get to my base. So that means I want to move the decimal point left 2 spots. So in 16.8 centimeters, if I move the decimal point left 2 spots, I would be at 0.168, and then my units now would be in meters. 19.7 meters is already in my base unit, so I'm okay there. And then in my 0.14 kilometers, to convert that one to meters. So to go from kilo to my base, we're going to want to go 1, 2, 3 units to the right. So if I take my 0.14 kilometers and I go 1, 2, 3 units to the right, I'm going to need a filler 0, so I'm going to end up at 140, and then meters would be my units. And then again, the last unit I was given was 240 meters. That's already in meters. All right, so let's go ahead and add these up. So my first thing I want to add is 0.168. And then I have 19.7. So remember, when you're adding up a bunch of decimal numbers, you want to line them up with the decimal point. The next thing I want to add up is 140 meters. So that would be 140. There would be the decimal point is after the 0. And then 240 meters. So 240, and then there would be my decimal point. When I add these up, I would get 399.868, and then my units would be in meters. So now we have to pay attention to what level of precision we want to write our final answer to. So we're going to round this to the least precise measurement. So I need to find the measurement or the precision of each measurement I was starting with, so I know then how to round this. So this first measurement, the 0.168, This has the precision to the thousandth spot or to 0.001. The next measurement has precision to the tenth spot or to 0.1. My next measurement, the 140, has precision to the tens spot, or to just 10. And then my last measurement, which is the 240, has precision also to the tens spot. So looking at these levels of precision, the least precise measurement would be either one of these last two that are to the tens spot. So if these are my least precise measurements, I'm going to round my final answer to the tens spot. So looking at here, the number that's in my tens spot is a 9. The number to the right of it is also a 9. Since it's 5 or bigger, I'm going to round this 9 up. And this 9 doesn't have anywhere to go to other than to bounce the next number up. So this is going to be to 400. But since I'm rounding to the tens spot, this 0 is significant, so I'm going to put a bar over it. So my final answer is 400 meters with a bar over the 0 that's in the tens spot to show that it's significant. All right, for additional practice on adding and subtracting measurements and then following the level of precision to answer it, that would be reviewing the material that's in section 4.5. All right, so then for the next one, we're looking at the measurement 2.135 centimeters. We're going to find its accuracy, precision, greatest possible error, relative error, and percent of error to the nearest hundredth of a percent. So the first question about accuracy. Accuracy is also asking how many significant digits there are in the number. So at 2.135, this one's pretty straightforward because there's really no zeros in the number. So this one has 4 significant digits. So the accuracy of this number is 4. Precision is asking us for the significant digits, what is the place value that the last significant digit ends? So the last significant digit is this 5. That 5 ends in the thousandths spot. So the precision is 0.001 or to the thousandths spot. All right, so then the next thing we're asked is what is the greatest possible error? So the greatest possible error, which I'm going to abbreviate GPE, is half of the precision. So in this case, since my precision is 0.001, if I multiply that by 1/2 or times 0.5 in my calculator, depending on the type of calculator that you have, on my calculator it showed 5e negative 4, so this means this is going to be in scientific notation. This is 5 times 10 to the negative 4th power, which means then in this front number, this 5, I'm going to move the decimal point left 4 spots. So if I move the decimal point left 4 spots, 1, 2, 3, 4, I'm going to need a couple filler zeros in here, specifically 3 filler zeros. So my greatest possible error is 0.0005. Or if you're allowed to, you could express the final answer in its scientific notation form, which would be 5 times 10 to the negative 4th power. All right, so the relative error, do this over here. The relative error is the greatest possible error divided by the measurement itself. So on this particular problem, that would be the 0.0005 divided by 2.135. Popping that in your calculator, you get the relative error being 0.000234. The percent of error to the nearest hundredth of a percent just means I want to take my relative error and I want to write it in its percent form. So as a reminder to go back and forth between decimal and a percent, you're going to move the decimal point left 2 spots. So if I move the decimal point left 2 spots, I would end up at 0.0234%. Now in this one, I only want to take this to the nearest hundredth of a percent. So looking at my percent, 0 is in the 10th spot, 2 is in my 100th spot. So the number to the right of that is 3, which is not 5 or bigger. I'm not going to round my 100th spot up. So my final answer would be 0.02%. Rounding to the nearest hundredth of a percent. All right, very cool. So these skills, if you want additional review, accuracy was talked about in 4.1. Precision was introduced in 4.2. Greatest possible error was also talked about in 4.2. Relative error is looked at in section 4.7, and percent of error is also looked at in 4.7 for some additional practice. The last question we're going to look at is going to get into setting up a proportion and proportional reasoning, which is explored in section 7.2. So the last question says the scale on a map is set to 1 centimeter is equivalent to 10 kilometers. If two cities are 4.8 centimeters apart, what is the actual distance between them? There's a couple different ways to set this question up, but if I want to set this up in a proportion, just to kind of show you what that looks like, the key thing when setting up a proportion I would recommend is leave the units on your answers. So we were given the information that 1 centimeter is equal to 10 kilometers. So I'm going to create a ratio of 1 centimeter in my numerator and 10 kilometers in my denominator. Now that's the given information, or the given relationship. So now I'm going to look at what I'm trying to solve. Now I was given, for the thing I'm trying to solve, that I have 4.8 centimeters. So notice that centimeter information is in the numerator. So when I go to set up my second ratio, my 4.8 will also be in the numerator because the other ratio has centimeter information in the numerator. So I have 4.8 centimeters in the numerator. The actual distance, or the kilometers, is unknown. That's in the denominator. Now these two ratios are going to be equivalent to each other because they have to maintain the same relative relationship. So I can set these ratios equal to each other, and ultimately then I end up with a proportion. Now in a proportion, the cross products must be equal. And when I say cross products, I mean what you get when you multiply the numbers on the diagonals. So on the one diagonal, I get 1 times x. On the other diagonal, I get 10 times 4.8. And I can set those two products equal to each other, because that's what must be true in a proportion. 1 times x is the same thing as just saying x. 10 times 4.8, multiplying that by a power of 10, I'm just going to move the decimal point right 1 spot, so that would be 48. Now I don't have to do anything more special to solve for x, so the value that's down here is because it has to be 48, and then my units for denominator information must be in kilometers. So 48 kilometers is my final answer.